Example 3. The letters A, B, and C are marked on the histogram. All right, so we see the markings. Here's A, B, and C. And remember, this is called a histogram. Why is this a histogram? Because the bars touch. The question is, determine which point is the mean, median, and mode. So looking again at these, we want to see which of these is A the mean, or is A the median, or is A the mode. Before I tell you the answer, let's talk about some shapes. And so we're going to introduce a normal distribution. And so normal distribution has this shape where it's symmetric. Symmetric means it looks the same on both sides. So this side looks the same as this side. So this is symmetric. You can hear a lot of names for this. They call this normal. They call this sometimes they'll say approximately normal if it looks a little, look different on one side than the other. They call this a bell shape. We want to also introduce is when it looks way different. So I can have most of my information. So I can have all my information mostly on the left. There's a tail, we call this right here. This is the tail. The tail is on the right. So this shape here is said to be skewed right. And when I think about the word right, I think about the location of the tail. Okay, so this indicates the location of the tail. That's how you can tell these skews apart. Let's take a look at a skewed left. So I'm going to see the tail on the left and most of the data on the right. So the tail on this case is on the left and most of the data is on the right. So this is said to be skewed left. All right, so these are some important shapes you're going to see throughout our course and throughout Math 1342, which is the normal shape, skewed right, skewed left, and a couple of others, but I wanted to introduce those. So let's take a look at our shape that we have currently. It's like if I take a really thick blanket and I throw it over these bars, so it's not going to show all the details on this, but it's going to show the overall shape. So notice the overall shape of this graph is going to be like this. And we're looking at this tail. The tail is on the right. So this graph is said to be skewed right. Now, with that information, I can give you a fact. And this is going to answer your question. The graph is skewed right. All right, so this is a fact. Since the graph is skewed right, this means that the mean is greater than the median, and the median is greater than the mode. So we're going to label our stuff. All right, let's get ready to tackle this statement. Now that you know the fact, let's take some time to analyze these bars. Now, a common mistake is to look at the height of the bars. We are not looking at the height of the bars. We are talking about the data. So this A represents a value of 3. Take a look at A is going to be a value of 3. Where am I reading this 3? I'm reading this value here because this bar contains numbers like 3. B contains numbers like 4. And C contains numbers like 5. Okay? Do not be fooled by the height. I know a lot of students want to come in and say, oh, well, this is the bigger bar. So when you say mean is greater, that must be the mean. When we're finding mean, we are finding data. Take a look back at the other stuff. See, we are finding data. So you need to look at what's actually inside the bars. Ready? Let's tackle this. It says the mean is greater than the median. So if 5 is the mean, then B, which is 4, would be the median. And it says the median is usually greater than the mode. So we're kind of going in order. In a graph that is skewed right, the mean will be the biggest value, which is C. The median will be smaller than the mean, which is B. And the mode is usually smaller than the median. So this is going to be the mode here. Two take-home facts from this problem. If you're thinking, should I know all of this? Yes, you should know the shapes, bell shape, skewed right, skewed left. And then you should know the general idea behind skewed right and skewed left. In this case, we learned about skewed right. The mean is greater than the median. The median is usually greater than the mode. Then remembering to read your data from your histogram, not the heights of the bars. Our overall answer here